Let's dive into a fun example of using fine-tuning with OpenAI to fine-tune a large language model to do something specific, like, for example, speaking like the fictional character Data from Star Trek: The Next Generation. What I'm going to do is take an existing LLM and feed it all of the scripts from Star Trek: The Next Generation, and specifically extract everything Data ever said in the entire series, along with who said it to him. So for example, in this exchange here, we can train OpenAI saying, when Picard says, "You will agree, Data, that Starfleet's instructions are difficult," Data's correct response would be, "Difficult? How so? Simply solve the mystery of Farpoint Station." And by fine-tuning the model, by training it on everything Data ever said throughout the entire series, the model will get very good at talking like Data, which is pretty awesome. Now, if you're not familiar with Star Trek, all you need to know is that it's a science fiction show that happens on a starship. Data is an android. And as an android, he talks kind of funny. You know, he never uses contractions, for example. He doesn't have any emotion, and he's sort of trying to figure out how to be human. He's a sort of a Pinocchio character, if you will. So we fed this data into our model. Now, the first thing we need to do is extract that information in such a way that we can feed it into the fine-tuning. So, you know, when Picard says something, we need to know how to extract that from this script. So how do I know this is Data's line? How do I construct that into an actual piece of data, structured data that I can feed into our model? And to do that, I've written a script. So I can't give you a copy of these scripts because copyright stuff, right? But, you know, if you were to, hypothetically speaking, go and search for it, just look for Star Trek scripts, you'll probably find it pretty easily. All right, but I had to write a script to take the scripts and transcribe these into something I can use as input for fine-tuning. And that's what this script is here. The details aren't terribly important, but the general idea is that I look through the entire script and I search for single words that are all caps on their own line. And typically, this indicates that some character is about to say something. Once that happens, I take note of what that character is, in this case, Data, and I just start reading until I encounter a blank line. And so for each line I encounter before the next blank line, I append that to the line for that character and keep going on and on and on. Now, in order to give things more context, I'm also extracting whatever was said before that line, right? So I want to say, you know, what was Data being asked before he said something? So I'm just going to keep track as I go of when Data says something, and then also output whatever was said before that in a piece of structured information. That's all this script does. So to be honest, I used ChatGPT to write some of this. So I had to strip out anything that was in parentheses, because there's a lot of stuff in scripts where they're like, interrupting, delighted, sort of direction of how to act there. And I don't want to capture that. I just want to capture what they actually said. And also there's a function that checks if we're encountering a line that's a single word that's all caps. That probably indicates that a character is about to say something, because all of the character names happen to be one word. Just kind of exploiting that knowledge there. We have a little convenience function here to process all of these scripts within a given directory, because there were 9 seasons of Star Trek: The Next Generation, and we have to slog through all of them and process each one individually. Here's where I actually go through and say, all right, let's go and extract every individual line that each character said in each script. When I'm done, I'm going to go through everything that everybody ever said, and if it's Data saying something, I'm going to print out the previous line from whoever was talking to Data, as well as what Data's response was in this JSON-L format at the end that we'll look at in a moment. And the guts of it is this extract character lines function here. Its job is just to try to figure out what are the actual concatenated lines of dialogue that aren't split up across multiple lines in the script itself. So if you want to study this, you can. If you want to apply this to some other script, you can as well. Most scripts are of a similar format, so it shouldn't take a whole lot of modification if you want to adapt this to scripts for your favorite movie or your favorite TV show and create your own AI version of your own favorite character. There's a certain poetry to what we're doing here, though, because the character Data is an AI. So we're making a real AI of a fictitious AI, which kind of makes my mind blown. Here's the final output of that script here. So you can see for each line here, we have some structured data. This is JSON-L format. And every line needs to contain a prompt and a completion. That's the format that OpenAI expects. So for each line, we have a prompt of whoever said something to Data. In this case, Picard said, "You will agree, Data, that Starfleet's instructions are difficult." And then Data's completion, what Data said in response was, "Difficult? How so? Simply solve the mystery of Farpoint Station." Now notice a few things that are a little bit weird here, okay? There are some quirks to how OpenAI expects this data to be structured so that it can actually feed it into the underlying transformer model that makes up this large language model and fine-tune it and train it further. First of all, we have these prefixes here that identify who's talking. So by saying Picard, blah, or Worf, blah, or Troy, blah, or Tasha, blah, I can train this AI on how it might respond differently to these different characters. So if I say, when I'm done with this, I'm making a chatbot, I can pose as Troy, and data will probably say something, well, counselor, because it knows that Troy is the ship's counselor. It actually works. It's pretty cool. So there's that. There's those labels. Strictly speaking, you don't need to say data every time because it always says data for all of these responses, for all of these completions, but it does make the output look more like a script to have that in there. Another thing worth talking about, notice these little 3 hash marks. That's basically a token that I'm using to indicate the end of the sentence there. So this is just saying, Picard's done saying something, I want you to generate text in response after this point. So transformers, that's the T in GPT, they work in parallel, right? So it just takes in all of these words all at once, and the only reason it knows that it's time for it to say something is that it encounters some special sequence there, some token that it's learned to associate with the task of doing something in response. Maybe that's doing a translation. In this case, in this training data, I'm saying, well, you should pick up on the fact that whenever I say pound, 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 that means data should say something in response to this line of dialogue. Also, one more quirk, and this is documented in the OpenAI documents for the API, you do need to start with white space in the completion for some reason. That's just how the tokens work. And also you need to have a stop token at the end. That can be anything as long as it doesn't appear in the rest of the completion. In this case, I'm just using the token end to signify that data's done talking. And then when I go back and actually use this model, I need to specify that end is my end token. So that way, when the transformer is generating output from data, when data is saying something, it will know when to stop. Otherwise, it would just keep on babbling on and producing nonsense forever. But by training it as to when it should end, it will actually give me complete sentences and not ramble too much. And even though data is known for talking too much, in reality, in these scripts, he's usually not saying a whole lot at once. That's just how TV series work. So you can see we actually have, in total, 6,596 lines of dialogue here. And each one is actually 2 lines of dialogue, the person who said something and what data said in response. So let's do something with this. Let's figure out how to actually feed this into OpenAI and what it costs. So OpenAI has a little guide here of how this all works. It's quite easy. So if you're watching this in the context of our larger machine learning course, you've already done these first 2 steps of installing the OpenAI package for Python and also specifying what your API key is. And once you've done that, once it's been exported as that specific environment variable, you don't need to deal with it anymore. You'll automatically be authenticated. Preparing the training data is the next step, and that's what we've already done, right? So we've done our best to prepare this in a format that will be compatible with OpenAI. But the good thing is they provide you with this data preparation tool. So I can just call this script and it will validate my data before I start spending money trying to train my model with it. So that's very handy. You know, if something was wrong, it will tell me up front before I waste any further time or money trying to process invalid data. So let's go ahead and run that. So what it's telling me to do here is call OpenAI. So I can just say OpenAI tools find_tunes.prepare_data and then -f and a path to the file that I want to process. For me, that's data_lines.jsonl. And it will go and chew on that. And it will tell me you have 6,627 prompt completion pairs. 43 of them are duplicates. So we may as well get rid of those. I did do my job and have all the prompts end with the suffix pound, pound, pound. All of my completions start with data. It says I don't necessarily need to do that, but again, I want to because I want my response to look like a script. And it checked that all completions are ending with a consistent suffix as well of end. So it's going to allow me to automatically fix things that it thinks should be fixed. Do I want to remove the duplicate rows? Sure. Yeah, why not? Save me a few tokens on training. Do I want to remove the prefix from all completions? No, I do not. I want to keep that. And now we'll go ahead and write a new prepared version of that file called data_lines_prepared.jsonl. And now I can actually kick off a fine-tuning job using that prepared data. To do that, I would say OpenAI API find_tunes.create-t and then a path to the prepared training data that I have. That's going to be data lines prepared.jsonl, and then the name of the model that I want to fine tune. Now, here's where things get a little bit complicated. I actually chose the Davinci model because at the time of this recording, fine-tuning for GPT 3.5 or GPT-4 was not yet available. They say, however, it will be available soon, and once that happens, these older models like Davinci and Ada and Babbage are going to go away. So if you are following along and doing this on your own data, it might give you an error on Davinci. If so, refer to the current documentation here as to how to actually do this on GPT itself, and you should get even better results. Now keep in mind this costs real money. So you will be charged by the token on this fine-tuning, and it will also take some time. So it estimates about 4 hours to complete this. A lot of that time's just spent waiting in line to get into the queue there, and that's okay. Now, I'm not going to make you sit here and wait 4 hours for it to complete, but here's a screenshot of what happened when it completed for me. You can see that it went off and created a fine-tune job, and there are ways to connect to that and follow the progress as it goes, to keep an eye on it. It gave me the total cost. In my case, it was $27.92. I think that's a pretty good deal for creating your own Commander data. And you can see I was number 6 in line for this time. By default, it will do 4 epochs of training, and by default, it will choose reasonable hyperparameters for you. There are ways of specifying those yourself, though. If you refer to the documentation and go to the API reference, it will give you more detail on the fine-tunes API. And you can see you can do things like specify the number of epochs if you want more than 4. 4 worked out really well for me, though. You can also specify your own hyperparameters like batch size and learning rate multiplier and prompt loss weight and all this other stuff, but by default, it will just default to reasonable values. And this is very, very helpful because if you were to try to do the same thing using like Amazon SageMaker, it would go off and do this whole hyperparameter tuning thing and end up training this model many times trying to converge on good values for these hyperparameters. But helpfully, OpenAI gives you some really good guesses to work from on the first try, and this really helps keep down the training time and the training costs. But you do have the flexibility of providing those by hand and doing your own hyperparameter tuning if you so choose. Anyway, once we were done with that, it gave us back the model name that it created. So this is our new fine-tuned model. I can now refer to that model within my further work using the API or just using the playground. So let's do that, and let's see what we actually get out of it. So let's go to the playground from openai.com and talk to data. So I can select complete. Again, that's simply because the chat API does not yet exist for using your own models. Again, when you're watching this, that might have changed. I'm going to set the model to the one that I just made. That's simulating data. The maximum length, we can bump that up to around 1,000. And the stop sequence we have to specify. For us, remember, it was end. So I'm going to say, when you see the token end, that means data should stop talking. And now we can just talk to data in the same format that we fed it data before. So let's ask data something. We have to say who we are first. Let's say I'm pretending to be Picard, and I'm going to say, lay in a course, Mr. Data. And I need to do those 3 pounds to provide that token that says data should say something in response. Let's see what data says. Let's hit submit. Sir, I have cross-checked the survey of which Mr. Worf is speaking, and it lists 5 Federation vessels wow. That's a very data-specific thing to say. And I can regenerate that too. Note that the temperature is set to 1, so there is a fair amount of randomness in what data is saying here. So if I regenerate that, I should get something else. Aye, sir, course plotted. Warp 6 heading 213, which is a very Star Trek thing to say. Let's do one more. Aye, sir. Well, it's short and sweet, but an appropriate response nonetheless. Course laid in, sir. Yep, that's probably what he would actually say in the real script. Now, just to prove that this is coming from my training and not something that was already in the underlying Davinci model, let's set that back to just plain old Davinci. Text Davinci 003, which is a pretty complicated model, by the way, and regenerate it again. And now it doesn't even know about data. I mean, it's giving me a reasonable response, but it thinks it's Commander Williams. Who the heck's that? Let's go back to our model, which knows more about Mr. Data, and let's ask it something else. How about we could pose as, I don't know, Geordie, and ask Data, how's Spot doing today? Bang, bang, bang. Make sure I got the right model selected. Everything looks good still. So clearly it knows that Spot is Data's cat. And data is responding in a very data-like way. The absence of progeny has created considerable anxiety in Spot. Even during her periods of inactivity, she soils the litter box much more frequently than normal. Wow, that's pretty impressive. So let's pretend we're Troy and say, data, take us into orbit. I don't know. Maybe Troy's in command for a change. Estimated orbital period is 26 minutes, 14 seconds. Let's try another one. Huh, but the captain. Oh, wow. I think I see what happened there. Data's saying, hey, Troy doesn't normally give that order. The captain does. Kind of picked up on that. Counselor, what are you doing? Oh, that's hilarious. So first of all, it's picking up on the fact that Troy is the counselor. It learned that from the script. And it's also picked up on the fact that normally Troy would not give that order. That comes from Picard. Let's try one more. Geordi. Data, I need to adjust your positronic matrix. And ironically enough, you can think of these transformer models as a giant matrix. So we kind of made a positronic matrix here, didn't we? My cortical and cranial pathways are not currently utilized. Good technobabble. I do not think that would be advisable. I am still considering a future. What? That's getting weird. I'm already activated. Notice, however, that it is talking like data. It's saying is not instead of isn't, and I am instead of I'm. So it definitely learned that data does not use contractions, which is pretty cool. Let's do one more just for fun. Let's pretend I'm Worf. Locking main phasers. Target the shuttle's engines. Data's given advice on what to shoot for. 30 seconds from contact. So we're basically, Captain, where he's about to say that he detected some strange anomaly on the sensors, right? Again, just for comparison, let's go back to the unfine-tuned model and see what it does. Woof woof, it's just complete nonsense, right? It doesn't even know who Worf is or what's going on here. So you can see the fine-tuning actually worked. We've trained it how data from Star Trek actually talks and responds to different situations, even to different people. So we've kind of made our own data here, our own real AI of a fictitious AI with $30 and a couple of hours of time. What a time to be alive. You know, that's kind of cool. So that's fine-tuning in action and a fun application of it. As a challenge, if you want to go and apply the same script to your own favorite TV show scripts or your own favorite movie scripts, every script is going to be formatted a little bit differently, so you might have to adjust that Python script to extract lines from it, but have some fun with it. You can create your own little AI versions of fictitious characters and talk to them, which is kind of fun. It's not just kind of fun, it's a lot of fun, and it's an impressive thing to show people. I love it. Fine-tuning in action.